Okay, we're live. Hello, everyone. Welcome to another edition of the iOS Lead Essentials podcast. I'm Mike.
And I'm Kayo.
And this week, we're going to be replying to some questions about automated testing strategies in iOS.
So we're not going to cover every testing strategy, but the most common ones.
Exactly.
Starting with, what is unit testing?
Or isolated or micro-testing.
Yes, the industry cannot agree on a term for a unit. So what is a unit?
Right.
It depends who you ask. But the central idea behind unit testing is to test a single component at a time in isolation. That's why you may call it isolated tests or micro tests, because they are testing just a tiny portion of your code base at a time.
Exactly. And you do so without communicating with other real components. We're talking about isolated tests, isolated components with mocked or stubbed behaviors.
So no network connections, no network requests, no database requests,
nothing.
No flakiness.
No flakiness. We're talking about deterministic behaviors that they will yield every single time the same result. Green, hopefully.
Right. So unit tests should be reliable. Every time you run the test, you should get the same result, regardless of the system state, because you don't keep state in unit tests.
Exactly.
So you should be able to run those tests several times a day. They are fast and reliable.
That's why you should be able to do so, because they are extremely fast and reliable.
Well, they should be fast and reliable.
They should be, yes, yes. They're very cheap. They should be very cheap to write.
And to maintain.
Mm-hmm. Exactly. And to maintain. That's why in the testing pyramid of allocating tests in your system, the unit tests are the foundation of the pyramid. The base of the pyramid. Exactly.
That's it. Unit tests are fast, reliable, and cheap to create and maintain. Thus, they are the foundation for your testing strategy. Or they should be.
Yes. And they are written by developers.
Yes. You write it in the same language that you're writing your application.
Exactly. There is no business language or any QA type of tool that can be used. We are talking about the programming language that you have written your system in, because you are going to reference your system in your unit tests. The implementation is going to be referenced in the test code.
And since you're not talking to real backend servers, you don't even need to have a backend ready to write them. As long as you establish a contract with the backend, you can start writing those tests at any time.
That's exactly right. And that's very useful because you're not blocked. You're never blocked.
Yes. So for example, in iOS, when you're just testing a class in isolation without talking to any other system, that's a unit test.
Yes.
For example, if you're testing a view model, you invoke a method, pass in some input, and you assert the value get back, the output, in isolation, with no views, no controllers, nothing, just the view model. You can prove that the view model does exactly what it's supposed to without having to instantiate the whole object graph or even run the application. You don't even need the simulator.
Exactly.
So that's unit testing or isolated testing or micro testing, which should be the foundation of your testing strategies, but should not be the only testing strategy as well. So next question, what is integration testing?
Integration tests check the interaction of two components as a group.
Two or more.
Two or more components. Yes, exactly.
Ideally, you don't want to instantiate the whole application and test the integration of everything at this level. That's why it normally limits to 2-3 components collaborating.
Yes.
But there is no limit. Ideally, just a few components, a small portion of your application collaborating.
That's it. Exactly. And integration tests are the second layer of the testing pyramid above unit tests. So that means we allocate fewer tests to check components in integration. And of course, that's because checking more than one component is going to be more expensive. That means that the tests are a bit harder to write and they can take a lot more time to execute.
Right.
And in your development process, that means that you don't want to be blocked by the tests running all day long. You want fast and reliable tests. And integration tests, well, sometimes might not be fast and might not be that reliable.
Exactly, especially if you are testing the integration with core data, for example.
Mm-hmm.
That's going to actually persist data in disk, or you are testing the integration with an external system through some kind of HTTP connection.
Right.
So it can be slow and flaky, because if the system is unresponsive, the test is going to fail.
Exactly. Well, if you're going to hit the network, if you're going to hit the database, there are many, many things that you do not control. So if you don't control them, then the result is not going to be 100% deterministic. It's not going to be 100% exactly the same every single time.
Exactly. And there are some behaviors you cannot easily replicate in integration tests. For example, it's very hard to replicate a database error or a network error because it's just unreliable.
Yes.
Just like you cannot reliably reproduce a successful connection.
Exactly.
Because it's out of our control.
Yes.
So if you need this level of control to test edge cases or error cases, you should probably use unit tests for that. And you test more of the happy path in integration to make sure that the components collaborate correctly. Because maybe just the unit test is not enough. But the ratio of number of unit tests for integration tests is completely different. You should have a lot of unit tests and a few integration tests. That's why it's the second level of the pyramid.
Yes.
It represents a small portion of your tests. So integration tests are important, but they should not be the foundation of your testing strategy or the only testing strategy as well. They should go on top of unit tests. You should be 100% confident in your unit tests, and you add the integration tests to make sure the collaboration also works. And again, you don't need to test the whole integration, the whole application working. You can instantiate just a small portion of your objects, of your components, and test them in integration.
Exactly. I mean, an example of that would be a network request, welcoming the response, mapping it, and propagating it to the rest of the system. Imagine how many components are involved, or how many actions or operations rather are involved in such operation.
Right.
You can even go one step further then and check integration as well, the database. Let's say you ask for the data from the network, you get it, and then you save it, you persist it in a database, and you want to make sure that all the round trip of the data actually works.
So there's a lot of objects integration there.
Yes.
There is the HTTP client, there is the mapper, the models, there's the persistence, there is some kind of coordination in between those objects, maybe some business rules validating the data, adding some expiration date to the cache, and etc. So maybe you can even break this down and say, I'm going to test the network connection and integration, just the mapping and the HTTP client. And in another test, I'm going to just test the persistence. If I can prove that they both work on their own, this also proves that they work in integration. So you don't need to compose all those fragile operations together. It's a choice.
Exactly. I really like what you're saying, because imagine if you have to check all the error cases, all the possible error cases in integration, right?
Yes.
The tests would take so long, and you have so many error cases that you will need to check, that it's just going to be like instantly it's going to become a bottleneck if you're after a 100% code coverage there. So yeah, I like that. The integration tests, you want fewer of them. above the unit test foundation of your testing strategies.
Yeah, just covering the things you cannot cover with unit tests. If you can cover 100% of feature with unit tests, that might be enough. You might not need integration tests.
Yes, agreed.
But if there's any kind of complicated collaboration between objects, it might be valuable to use integration tests just to cover the integration part. And in integration tests, you can also replace some of the objects in the integration with some kind of test double. You don't need to use the whole integration as real implementations.
Right.
For example, if you want to test a network failure, you might have to replace the network client with some kind of test double so you can control that failure. You can force a failure.
Right.
So you can replace just one instance in that integration just to control some edge cases. That's fine as well. So that's integration testing. Next, what is UI testing?
Okay. We have the definition by Apple here. Now, Apple states, UI testing gives you the ability to find and interact with the UI of your app in order to validate the properties and state of the UI elements. UI testing includes UI recording, which gives you the ability to generate code that exercises your app's UI the same way you do, and which you can expand upon to implement UI tests.
Right. So Apple gives us a framework for performing this UI testing, which allows us to record us interacting with the application and then repeating that, automating that process. So we don't need to do it manually every time.
Yes.
So UI testing is a kind of black box testing. It tests through the UI. You don't have control over the application.
Mm-hmm.
You are actually instantiating the whole object graph, running an application, and interacting with it. So you have much less control over replacing behavior or controlling the state of the app.
Yes.
You need to manually perform the actions to get to the state you want.
That's exactly right. And the keywords that stood out to me of what you just said is you have to run the app. And that makes it very, very expensive. That's why UI tests are at the top of the pyramid, of the testing pyramid, because you want very few of them, because they take a lot of time to run, because you need to run actually an application.
And press buttons and wait for animations and etc.
Exactly.
Of course, you can speed up that, but if you compare a unit test and a UI test, a unit test takes 0.01 second. A UI test is going to take at least 5 to 10 seconds.
It's it's like 2 orders of magnitude more. Unit tests play at the millisecond level. UI tests play at the second level. So if you have a bunch of them, then it can easily become a bottleneck. And when it does, well, you're going to stop testing altogether. Yeah.
Yes. Of course, there are strategies to make UI tests faster and more reliable. For example, replacing the network stack with some kind of stub, or the database, or passing some launch arguments to the application so the application can put itself in the state you expect. But still, it's a costly strategy.
Right.
Even the frameworks used to interact with the user interface, they're not very reliable. They crash for many reasons. So you don't want to be running UI tests for hours and hours and hours. It can become a bottleneck in your process. But you want to feel them. If you have a very complex user interface or interactions, they're hard to test in isolation or in integration. You must have to run the app and actually test that.
Yes.
So you might need it. Not always, but you might need it. And if you do, who write UI tests?
Well, developers and QA testers.
Exactly. Like unit tests and integration tests, developers can write them. But you don't need to be a very experienced Swift developer to write those tests.
Mm-hmm.
With a little bit of experience with Swift and Xcode and Xctest, QA engineers can also write those tests. And if you have QA engineers in your team, it would be very beneficial if they wrote it.
Yeah.
And when should you write those tests? Well, ideally, you should write those tests with the QA engineers in the beginning. So ideally, you should also write the UI tests first.
Exactly. And it's a live process, basically. You can write the UI test first, and of course the system is not ready. So you jump into another testing strategy, gradually start implementing your components by unit testing them first. And then maybe, if you need, you can have a couple integration tests, making sure that your components work together. And at the end, your UI test will be passing if everything works correctly in integration.
That's it. So UI testing is a testing strategy that's going to validate your application through the user interface, like a black box. You have little control. Even though you can pass some launch arguments and do some trickery with the application, it's still a black box, and you can only evaluate values you see on the screen. You can only perform operations with the user interface, with UI elements, and validate what you see on the screen, like labels, buttons, etc. And they are slow and expensive. Thus, we want only a few of them, if any.
Exactly.
Next question. What is acceptance testing?
Acceptance testing is the process of validating that your app is compliant to the business requirement or the acceptance criteria.
Right. So who should write acceptance tests?
Right. Hopefully, the business folks can write the acceptance tests.
Right. So business folks meaning a business analyst that has direct contact with the business, with the decisions.
Exactly. These are high-level tests that do not touch the implementation of the system. They check everything in integration for specific scenarios, specific operations the system must do.
And since they are not written by developers, they are written in a high-level language, like English.
Exactly. That's correct.
And we have some guidelines for that. For example, the given, when, then from BDD.
Yes.
For writing these acceptance tests. So you don't need to be a developer to write those tests down in a high-level language. But then, a developer or a QA engineer is going to translate that high-level language to some tests that can run against your system.
Exactly.
So there's this high-level language that everyone can understand in the business, and it needs to be translated to something that can execute your system to validate the acceptance criteria. And there are tools for that, right? Like Fitness and Cucumber.
Exactly. The acceptance tests also live in the top part of the pyramid because they are expensive. They are very expensive to run, to execute, taking a lot of time because they're checking basically the whole system, whole features of the system in integration.
And usually as a black box as well.
Yes.
So usually you don't want to mock anything. You don't want to use test doubles for anything. You want to actually perform operations in your system in some kind of staging environment that replicates the production environment. So they can be slow because they're going to be running network requests. You're going to be interacting with the file system. So the results can be undeterministic.
Yes.
It depends on external systems working as well. So you want just a few of them just to validate the acceptance criteria. Remember, the foundation is unit tests. On top of that, go integration tests. And then you start writing more high-level tests like UI tests and acceptance tests. But you need this solid foundation. Because if you have to test everything with high-level tests, that's going to be extremely expensive.
Yes.
It's going to take a long time to run. The test is not going to be reliable. Thus, you're going to have to test things manually. Yes. And it's going to become a bottleneck.
Exactly.
So, you need to build a solid foundation first. So those can be important tests, but acceptance testing should not be your only strategy. Next question. What is end-to-end testing?
Well, we covered already, I believe. End-to-end testing is a form of integration testing that checks an operation from start to finish. In the example we gave before about making an actual network request, getting the response, mapping it, propagating it to the rest of the system, then you persist that response in a database. Well, That's an end-to-end test where you check what happens to the data from the network to the database.
So talking to multiple systems in integration.
Yes.
So it is an integration test, but specifically going end-to-end without any mocking.
Yes.
So they are also written by developers.
Yes.
Probably in the same language you're writing the application.
That's exactly right. Because you're going to reference the implementations of your app inside the tests.
That's it. So they're also expensive to run. If they go end-to-end, talking to a network, database, they can be slow and fragile. They can fail for many reasons, out of our control. So you want just a few end-to-end tests. When you have critical systems that need to operate correctly and you don't trust those systems. For example, if you're talking to a backend you don't trust, or if you're using a framework for persisting data that is like a black box, you don't have access to the code. Thus, you want to make sure that it does what you expect.
Yes.
So that's it. End-to-end test is a kind of integration test. You can also say that UI test is also a kind of integration test because there are multiple components in integration. And acceptance test is also a kind of integration test. Next, what is black box testing?
Okay. Black box testing refers to the process of checking the system's validity without having access to its design or its implementation.
Right, so it's literally testing through the binary somehow.
Yes.
Like in the case of UI tests,
That's
you're actually running the application and tap on buttons.
Exactly. You don't know how the system is being designed or written in the case of UI tests. In the case of acceptance tests, that's exactly the same. In the case of end-to-end tests or integration tests or unit tests, that's not the case. Because you would have to reference the implementation code in your tests.
Right. So we can say that UI tests is a kind of black box testing.
Yes.
And acceptance testing is a kind of black box testing as well. If you're testing application, not through the implementation, to some kind of high-level framework, then it's a black box. Just like a user would test your application. They don't know what kind of pattern you're using. They don't know anything about your application.
No.
They can only interact with what they see and with what is steppable.
Yes, that's exactly right.
That's it.
Can think of it as the automated version of manual testing, where you basically don't know anything about the guts of the application, of the design, of the structure, but you can interact through the UI there.
Yes. So black box testing doesn't need to be implemented by developers.
No.
If you have a high-level tool, like UI tests, where you can record the interaction with the user interface, anyone can record those tests. So that's it. Every time you test some kind of private source framework where you don't have access to the implementation, or you're using some kind of tool that's going to test the application from a high level to the user interface, that's black box testing. And they live in the top of the pyramid as well.
Yes.
Together with UI tests. You want only a few of them because they're not very reliable. And they interact with real systems. So it can be slow. Again, you need a solid foundation with unit tests and a few low-level integration tests. And then you build on top of that, if necessary.
Yes.
Next, what is snapshot testing? So snapshot testing refers to the process of taking a snapshot of your system or parts of your system and comparing it to a previous state. So for example, you can take a snapshot of some data structure. It was the output of an operation. Then you can run the operation again, take a snapshot of the output and compare it. This is usually used for validating the user interface, the rendering of a view, for example, because you can render a view, take a screenshot, which is a kind of snapshot, and store it. So as you refactor your code, as you add more features, you can keep taking snapshots or screenshots of that view and comparing to a previous version. If they are the same, actually checking the pixels. If they are the same, the visuals are still the same.
Yes. The diff. Checking the diff of the two pictures there.
Yes.
We should say here that snapshot testing is not like UI testing in many regards, actually.
Mm-hmm.
First of all, snapshot tests take a lot less time to run than UI tests. And that's because you can render your UI without actually running the application. While in UI tests, you can't do that. You need to run the application.
Yes. So you can take screenshots of your application during UI tests, but you don't need UI tests to take screenshots of your application.
That's exactly right. Yes.
You can render just a portion of your screen. You don't even need to render the whole screen.
Yes.
For example, you can render just a cell, take a snapshot or a screenshot of that cell, and store that state in your Git repo. So the next time you run the tests, it's going to take a new screenshot and compare to the old version.
Yes.
As long as they are the same, your UI is rendering the exact same view as you expect. And you don't need to run the application to do that.
No.
And this can be very fast. You can only render the view, a small portion of the view, and compare to a previous version. That can be very quick.
That's a good thing. Exactly.
So snapshot tests are often written by developers. But since you can also take screenshots from UI tests, QA engineers often write those tests as well. Right? There are a bunch of tools that can help you take screenshots of your application, store them, and compare with previous versions.
Exactly.
And again, snapshot test is not just about user interface. You can snapshot anything in your application, any data structure, any result of operation, and compare to a previous version. The problem of using only snapshot tests as your strategy is that if the test fails, for example, 2 versions of a data structure don't match, you have no idea why. It could be anything.
The feedback can be not good. Exactly. So that's why you also want few snapshot tests, perhaps in certain areas of your application and your system. You don't want to rely on them. Although they can be fast, you don't want to rely on them.
Yeah, they are faster than UI tests.
Yes.
But they're still much slower than simple unit tests.
Exactly.
So you can add it to your strategy, but not as the only strategy and never as the foundation.
Yes.
They can go on top of unit tests.
Yes.
But they usually test more than one component in integration. So they are a kind of integration test. Thus, they go above unit tests in the pyramid. You want just a few of them. All right. Next question. Which testing strategy is best? Which one should I choose? So we have many testing strategies, but doesn't mean if I choose one, I'm saying no to all the other ones.
That's exactly right.
You need to create your testing strategy by combining all those different approaches. So if you have to say which testing strategy is best, it depends on your application, but you need a solid foundation. The foundation should be fast and reliable. So unit tests. On top of that, you can test the integration of your components with integration tests that can test integration of specific parts of your application. You don't need to run the whole application. And if you're still not confident, you may need some acceptance or UI tests on top of that.
One thing I would like to mention here is that this testing pyramid we've been talking about, and it's out there, of course, it's like the standard in the industry. Sometimes it is being shown as the 3 layers are like equal. The 3 layers, meaning the foundation, the unit, then the integration, and then on top the UI, acceptance, and the rest. These are not equal parts in the in the pyramid. Excuse me. The unit test should be the majority of the test, and we can't stress that enough.
Yes, the testing pyramid is a good analogy to how to distribute your tests.
Yes.
It doesn't mean you need UI tests every time in the top of the pyramid. You could have a lot of confidence just with unit tests and integration tests, depending on your use case.
Yes, exactly.
And some strategies might require a little bit more UI tests, but never more UI tests than integration tests, and never more integration tests than unit tests.
That's a good rule. Yes.
That's it. The foundation should be fast and reliable. If you have that, then you can build on top. But until you have the solid foundation, no other strategy is going to help you in the long term.
And at the end of the day, the goal should not be to, favor unit over integration or over UI testing, right? The goal is to go fast and keep building the vision of the business perpetually. So testing is a fantastic tool that can help you do that. So I think of it in our terms of the goal is testing. It should not become a liability. That's very, very important, actually.
Mm-hmm.
You want it to be very, very fast. You want to be reliable. Now, if you meet these two criteria, then you're good.
Yes, because the goal of testing is to give you confidence. Confidence so you can add new features, change the current features, refactor your code, minimal cost.
Yes.
Because you want to go fast, and going fast is risky. The only way you can take big risks is by having a solid foundation. If you have the solid foundation, you can take risks because there will be no systemic crash in the system.
That's exactly right. So it doesn't matter, again, what frameworks you use for testing, all these preferences are secondary. The goal should be, is it fast? Is it reliable? Does it give me confidence? Am I confident enough to ship my version of the app?
Yes.
That's the question you need to reply to.
When you achieve a testing strategy that when you run the tests, they are fast, reliable, and if they pass, you are confident to ship the app, you achieved a good balance in your testing strategy. You achieved the goal. Now, if you run all your tests, they are green, and you're still not confident, and you're going to manually test everything, you spend all the time building the test suite, and you don't trust it. It's not helping you achieve the ultimate goal of going fast, taking risks, and creating profitable solutions.
Exactly.
So think of the goal first, and then you find a way to get there, and start with a solid foundation. Next question. I read about the benefits of testing, but it takes too long to implement. Am I doing something wrong? Should I abandon the idea of testing? No, you should not abandon the idea of testing.
Definitely not.
Because maybe it's taking too long for you to implement it right now. But you need to look at other teams. If there's a team 100% confident they can ship when the test pass, and it's fast and reliable, they prove that it's possible. There are bazillion of teams out there doing this and creating amazing software and amazing code bases. There is a delight to work on.
Yes.
So it's been proven that it's possible. The problem is that you don't have the skills yet. And that's fine. You're not born knowing this. You need to learn that.
It's one of those processes that there is no shortcut. You need to put the hours, you need to put the work. And by definition, we're saying that openly. You shouldn't expect results to click and come instantly, No.
The shortcut is to be part of teams that are good at doing this.
Yes.
It's learning from people that achieved it, that can teach you.
Exactly.
Because trying to figure this out on your own may never happen.
Yes.
It may happen, but it's going to take a long time. So this is a very hard foundation to build on your own.
Mm-hmm.
But you don't need to learn this on your own. There are a bunch of techniques, practices, and disciplines you can follow to achieve good results 100% of the time. You just need to learn them. So don't abandon the idea of testing.
No.
But find people that can teach you, that can guide you. Don't try to learn on your own, reading random blog posts everywhere. That's just going to make you more confused.
Exactly. And abandoning, I think that's it's too extreme. Testing is one of those processes that remarkable professionals will master. The value that they can bring through testing to the business, it's amazing, simply amazing. It's what will allow the business to keep moving forward confidently.
And most businesses understand that already. And it's becoming more and more a mandatory skill.
Yes.
Writing good automated tests, it's one of the mandatory skills to a remarkable career.
Exactly.
high-paying positions, working in exciting projects with remarkable people. That's what you gotta do. You need to learn those hard techniques. And it's hard. It's hard on your own. But you can learn from others. So try to get some training from your company. Ask your manager for some training. If you cannot get that, you might have to go out of your way to learn, to pay for those courses out of your own pocket.
It's an investment. It's not a cost. You're not paying something as a cost. You're investing in yourself. You're investing in your career. That's for sure.
It returns.
Yes.
If you are building valuable skills that is going to make you more valuable in the market, it's going to return. You learn a skill once and it delivers forever as long as you practice it.
Yes.
So you need to be careful with your sources so you don't waste time. That's it. Testing takes time to write and makes you less productive when you're not used to it. But don't abandon the idea.
No.
Get better and faster at it so you become more productive than before.
Yeah, agreed.
Next question. I work on a legacy code base with no tests. What testing strategies do you suggest to use? Well, that's a hard one.
Yeah.
You have this legacy code base, probably with a bunch of components that are not testable at all because there are no tests. They were not mindful about testing. So you need to gradually and strategically start implementing a little bit of each.
Yes.
When you have a bunch of components that are hard to test in isolation in a legacy code base, you might have to use some very high-level UI tests just to guarantee that the whole composition works, the whole application works, just to give you confidence to start changing the code and breaking down the dependencies. So I suggest you start with high-level tests that give you confidence to change the current code.
Yes.
But as soon as you start writing new code, create a solid foundation with unit tests and build on top of the solid foundation. So you might need some integration tests and maybe some acceptance tests or UI tests. But start with the solid foundation for new code. And you don't need to write tests for your whole code base in one go. Don't stop delivering features to refactor the whole code base.
Yes.
Every time you need to change anything in the legacy code base, you write a little bit of tests around that thing you changed. Maybe some UI tests to give you confidence to change it. Then, as you change it, you break down the dependencies and you test things in isolation. And little by little, you clean the code base. It's going to take time, but don't do it in one go. Do it as you go.
That's it. That's it. Very good guidelines and advice. Balance, basically. You need to jump from one strategy to another, and it's not easy to...
Yes, but the idea is to create a solid foundation of unit tests.
Yes.
They're fast and reliable. So you can run it several times a day.
Yes.
Every time you make a tiny change, you run the test. Make a tiny change, run the test. Make a tiny change, run the test. If your tests are fast and reliable, you can do this every 10 seconds, every 30 seconds.
That's the goal.
And the test should take less than a second to run.
Yes.
The unit tests. But if you cannot do it because the code base is a mess, you might have to write some high-level tests and clean as you go. Next question. My tests sometimes pass and sometimes fail. Can you suggest how can I improve them?
Okay.
Well, that's what we mentioned with flaky tests.
That's the definition here. Flaky or flakiness. It's when your tests sometimes are passing and sometimes are not.
Well, if it's a unit test that sometimes passes and sometimes does not pass, you have some unpredictable side effects in your code base.
Yes, exactly.
You should eliminate the side effects when testing. Now, if you're testing things in integration and you're actually talking to some external services out of your control, well, they're going to fail from time to time.
Perhaps increase the timeout, but that's it basically.
It's going to make things slower. It's just going to take longer to fail, right?
Maybe. Yes, maybe.
So if you have a unit test making network requests, replace that with a test double so you can control the system. And you test both the success and failure case. Test all the edge cases with unit tests because you have absolute control. In integration, if you're testing a bunch of components in integration and there's one part of the system that is not reliable, for example, a backend, replace it during integration tests.
Yes.
With something you can control, like a stub. Now you actually want to test talking to this external system that is unreliable. Then it's going to fail from time to time because it's an external system, it's out of your control, and it's unreliable. But the problem of testing an unreliable system that fails from time to time is that you're going to start ignoring failures. And maybe it's a fatal failure.
Right.
You're not going to pay attention because, this system always fails, so it's probably another flaky run. Just ignore it.
Yeah.
Other things that make tests flaky is if there's any dependency between tests. For example, you have 3 tests, and test 2 only passes if test 1 ran before.
So the order here of execution, you mean?
Yes. If there's any order dependency, you cannot run test 2 in isolation, for example.
Right.
Because it depends on the result of test 1. It's leaving some side effects in the system.
Yes.
You don't want that.
No.
You should be able to run only one test or run the whole suite, and they should be fast and reliable.
Yes.
So one thing you can do to find those flake tests, go to Xcode, go to your scheme, select your test configuration, select the test target, and enable randomize test order, and run the test a couple of times.
Yeah, that should do it. That should reveal the flaky ones.
Exactly. Because I've seen tests that start failing because the test file was renamed.
Right.
Because normally the tests run in alphabetical order.
Right.
So if by renaming the test, you change the alphabetical order of it, it may start failing.
Yeah.
That's a flaky test. You don't want that.
Yeah.
That can drive you insane.
Yes.
How renaming a test make it fail? It makes no sense. Well, if there's an order dependency, it does make sense.
Yes.
Everything that fails makes sense somehow. We just cannot see it.
Exactly.
So enable random order. Other things that make tests flaky. Race conditions. Enable the thread sanitizer.
Yes.
Other things that make UI tests unreliable. Executing code in background thread. UI code in background thread. Activate the main thread sanitizer. So there are a bunch of tools that can help you. But ultimately, you need to have the discipline of creating those isolated tests that don't influence each other. Eliminating side effects.
Exactly. And you need to be mindful when you're creating side effects in the first place.
Exactly. So globals are a no-no.
Yes, they are.
Because they make things more unreliable.
Yes.
They are shared state.
Yes, exactly.
So you should eliminate those globals as much as possible. Okay, I think that's it for this episode.
Okay. And if you want to learn more about automated testing strategies, go to academy.essentialdeveloper.com. That's going to do it for this edition of the iOS Lead Essentials podcast. We'll see you again next time. Bye, y'all.
See ya.